Sure thing. So we already ran through the first like registration bypass, and I'm glad that that seems like everyone picked up on that. You know, read the source code. There's always going to be comments left behind from developers or secrets in there. So that was vulnerability number one. Since it seems like a lot of people spent time on the Batcave, I'll start with that one. So if we go to the Batcave, we can see that the page loads, and then if you click the button, something happens and it says, "Nice try, you're not Batman." If we look at our HTTP history here, we can see, apologies if this is really small, but sequentially what happens. We load admin/Batcave, and some HTML comes back, and then it loads a bunch of JavaScript, the dist/bundle.js, which I heard some of you were looking into as well, which is really a big mess of obfuscated JavaScript, but somewhere hidden inside there is a React application. And then it makes a request to API/Batcave/authorize. And API/Batcave/authorize, I think you saw, returns a true or false. So I can take this API request and send it to the repeater. One thing I should have mentioned, sorry if you all were seeing this, if you get a response from the server that says 304 not modified, it just means that you've already got this data and it hasn't changed, and so the server's not sending it to you again. There's something in the web request that goes out that the server knows, like, oh, I've already given you this data. And since we know that HTTP is stateless, we can actually trick the server to always give us the data if we want. It's actually this header right here is a hash of the file. If we just delete that header and hit send again, we'll always get the response. We won't get any of the 304 content. So something to just be aware of if you want to see the response and you know it hasn't changed, but you just want to see it. If you remove that header, the server will have to respond with fresh data. So we see that this is requesting API Batcave/authorize is Batman is false, and it's not letting us in. I will actually show you the React code that's building up that component, so you can kind of get an idea of what's going on. So React is rendering this Batcave component, and it's using some if-else statements to determine whether or not you are Batman. And so this button that's called Enter Batcave is kicking off a JavaScript function called authorize user. And authorize user is sending the request to API Batcave.authorize and then setting a Boolean value whether or not the user is Batman. And if the user is not Batman, it renders the page that we've seen, which is nice try, you're not Batman. But if they are Batman, then it's actually going to render the page of the Batcave. This is bad code. This is bad vulnerable React code. Anyone have any ideas like what's wrong with this?
Well, you're not catching any errors coming back from your async.
Yeah, that's just because I'm a bad programmer, but that's not necessarily the vulnerability. But I'm definitely not handling, I'm not handling errors well or making, good reliable code here.
There's no authorization token.
The else is this. I mean, anybody reading the JavaScript can read the whole entire else statement.
Yep. Yeah, that's a good one. And someone, I forget who it was, saw that. They were like, well, I already see what the Batcave is because it's in the code. So that's the problem, because this is actually everything that's in my React app does get sent to the browser. So even if we weren't authorized, we'd be able to see what the Batcave should look like. But the problem is that we as attackers control, like I said, the requests that go out and the responses that come back in. So I'm going to try this again, but with intercept on.
So I noticed that I could take the cookie session and decode it from base64. It would give me a JSON item that I could change and re-encode as base64. But I'm still stuck on how to actually send that through. I'm trying to send it through as maybe I'm writing invalid maybe it's coming out invalid, and the page is just like logging me out when I do it. So.
Mm-hmm. Yeah, that's an awesome find. I'll detour real quick and show that. Sorry, I didn't catch who was talking, but they identified that this cookie here, that's session, is this long garbled string. But if you recognize and know encodings, you might be able to detect that that looks like base 64 encoding. So within burp, if we highlight text and we right click and say send to decoder, and then hit decode as base 64, we can actually see all the data that's stored inside that cookie. And it is JSON, and it is storing the information about who we are. So it is storing our username, our secret identity, how many credits we have, and our secret key. So I love the way you're thinking. You're already thinking like an attacker, like, well, I might be able to just change this to Batman, and then I'll just re-encode it as base 64. And I'll just use that as my cookie instead.
Well, I was actually attaching another key value pair that said is Batman true, and then re-encoding it, and then trying to attach that to this request that we're sending, because what I seen on your API authorize, where React just takes that incoming data and just immediately sets it to this. It just goes and sets it. It doesn't even like validate anything about what you just sent it. It just kind of sets it.
Yep. Yeah, love it. You definitely know the vulnerability. You're right. The problem with this with this React code is it's not validating the response that it gets from here. It's just immediately saying like is Batman or is not Batman and making the determination. So I like the way you're thinking here. Unfortunately, that's a rabbit hole, and that happens in pen testing. If you kept trying with that, it wouldn't work. But there's an even easier way to make this happen. If we go back and we turn intercept on, let's walk like step by step what happens here when we try to load the Batcave. So we hit enter Batcave, and immediately this request was fired off by our React application, right? The one we expect to see, API Batcave/authorize. And it's sending our session cookie, and it's sending some cache information. Let's remove the cache information because we want to see the response. But because we are controlling the data that comes back from the server as well, we can right-click, do intercept response to this request. So we'll send a normal authorized request, but we get the response that comes back from the server. And we see this response is Batman is false. Now to React, it hasn't gotten the response yet. React is still waiting for the server to actually tell us whether or not we're Batman. And here we're actually controlling what the server is telling React. So here we can actually change this value to true and then forward it on. And if we open up our browser again, React saw the response come from the server, quote unquote, but it really came from burp. And it saw that is Batman is true. And React said, oh, you're already authorized then, perfect. Because React didn't bother to actually validate that the response coming from the server was indeed a valid response. So we were able to tamper and modify the HTTP that came from the server and trick React into thinking that we're Batman. And Batman loaded up the Batcave and loaded our little GIF here.
I think I was getting confused on the intercepts, what stage I was at, like the because you have to click like forward a couple times. And in between that, it's like the request gets sent out. Yeah, I was getting stuck in there somewhere. I didn't even think about just modifying the one that came back.
Yep. Yes. It's a nasty little vulnerability that's actually unfortunately kind of common, where if you're relying in your client side code as like a Boolean check, or like let me just ping the server and say like, hey, am I authorized to do this or not? You have to be aware that attackers in our position can control what comes back from the server. So if we just if we just change the response that comes back from the server and say, yeah, we're authorized, we're admins, we're Batman, and React doesn't actually try to validate any of that, then you'll find, we can load the Batcave, or we can get into an admin portal that maybe we shouldn't have access to.
I'm kind of wondering what the correct way to code that is, because I probably would have wrote something very similar in React if I was asked to.
Yep. So the correct way, the core of the problem here is that our entire admin page is, or the Batcave, we'll call this the secrets. Let's just say like this GIF is super secret and we don't want it to see. We have it hard coded here inside the React application. A better way to code this is we don't ever want to put quote unquote secrets into our client application and then just try to hide them from the user if they're not authorized. What we always want to do is make sure we're fetching secret data from the server and have the server determine whether or not we're Batman. So like, what I would do is, all right, let's say like Mr. Wayne is also the secret because that's Batman's secret identity. We should instead just put like a variable there, and this GIF is also a secret, so we'll just put like the variable there. So this is all that the attacker would ever see, is just like variables without secret information. And instead of fetching like a true false, we should just fetch the name and the URL from the server. Does that make sense? So like basically any sort of authentication or authorization decisions need to be made on the server and not the client. So
Okay.
instead of like asking the server, hey, are we Batman? And then React makes the determination, we should just send a request to the server that says, load the Batcave, and the server should determine whether or not the Batcave loads instead of us. And then this might become like API/Batcave/content. So we're actually loading the secret content from the Batcave. And then on our server side code, we would check to make sure that the user is logged in and that they actually are Batman, and then determine what content we want to send them.
This might be a dumb question, but if you moved everything in the Jumbotron div into a separate component, would that be obfuscated in that JavaScript, or is that still not great to do?
No, it would still. Yep.
Yeah, I was able to see everything just about. They renamed some functions. So, for instance, the isBatman function that's called through some variable, a function named T. So it renames that function to T, and then T relies on P, which relies on E and R. So, yeah, that's all part of the Webpack aspect. And that's, yeah, that stuff there. If you scroll down to the very, very bottom, depending on your window width, it should be the Giphy should be about 1 or 2, 4 lines from the very bottom, even though technically it's all in one line. So there's the Giphy of them spinning around. And then there, right above that, you can see the misspelling for the duck cave. I was getting stuck as far as in this part here, about 2 or 3 lines up. You do have one call to isBatman, and that's 1, 2, 3, 4 lines up in the middle from the top of your current highlight. And that function's only called once. Yeah, and if you do a search for isBat, you got is backwards, but that's the only part where isBatman is ever even referenced. Because I was trying to go back further to find out, okay, where's the actual test? Where's the API source for it? To find out what possible username or password that it's checking against. And again, because I hadn't unloaded the jar or even opened up those things. So.
Yeah. So that's a really important thing to remember is, my React application, I'm writing in JSX here. Anything that is going into React is going to end up being sent to the client. So you never want to put anything secret or anything that you want to hide in your React code. Your React code should really just be a bare bones, like loading framework to then go fetch sensitive information. Maybe an analogy might be like, kind of what we're doing here would be like if I went to chase.com and Chase loaded every person's account balance and sent them to my client and then determined which one they wanted to show me in the browser, that's bad. Instead, I go to chase.com, Chase loads like a bare bones like page with no data, and then only fetches the data that I should be seeing from the server. We've basically just sent too much data from the server. because the Batcave and all the secret data for the Batcave is already in the client side, so it's already there. So you could either see it as that gentleman speaking did inside the obfuscated JavaScript, or we can just mess with the API responses and get it to render for us.
Okay. Yeah, I had no idea we can read the entire client-side source.
Yep.
That's interesting.
Yeah, you can see it. It definitely gets very ugly. This is Webpack for you. Like this is called transpiling. Like if you transpile JavaScript, you basically just take like this type of JavaScript, and then what it's doing is bundling it all together so that browsers of different types of browsers can all understand it. So this is really a mess to read, but it is possible to read it. And like attackers and pen testers will go through every little thing and millions of lines of JavaScript to see what they can find. So the only defense is to not put anything sensitive in there. Cool. So does that make sense?
Yep.
All right. Did anyone take a look at the location database?
I tried to tinker with that one, but I couldn't get anywhere.
So this is a pretty like easy form, or it's a pretty standard form lookup, right? It's our Justice League database of superheroes operating in cities around the universe. And so if we put in a location like Metropolis and we search, we get a response that Superman is operating in Metropolis. But and if we look in Burp Suite, what's happening is we are sending a post to locations with the city Metropolis in there, and it's rendering this table for us. Down here we see Superman and Metropolis. The hint in this one was, this is a database, so it's SQL. There might be potential for SQL injection. So one thing that we'd always want to try when we're testing this type of potential injection attack is let's just choose something bad, no results. But what happens if we put in just a bunch of different random special characters? We get a bad error. So I put some special characters in there, and I actually see that it spit out a SQL error. And the SQL error said unrecognized token, and then it spit out and said bad query, select star from locations where location like foobar, blah, 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 blah. So this if we see this as an attacker, is a good sign. If we see it as a developer, it's a really bad sign. It basically means we're interacting with SQL and throwing out some like bad errors because SQL is not understanding what we're trying to send it. So just gleaning the information we can from this, we can actually see exactly what the server is doing for us. Whatever we're putting in location, it's basically creating a SQL statement like this: select star from locations where location like foobar, and this is our search term. So if we want to break out of this and see if we can extract some other information, what we need to do is make our search term be foobar and then a single quote, and now here we can type any SQL we want, and that it will be executed. So some of the things that we might want to try are a classic like or 1 equals 1, and if we tried that, it'll actually dump out. You see we got way more responses, even though foobar didn't have any responses, because we added an or 1 equals 1 in there. It constructed a SQL statement. It was or true, and it dumped out everything in the database. So we see, or everything in the table, right? So we can actually see every superhero and the location that they're a part of. So we know we're actually writing like custom SQL here. I guess I'll just, normally this process would be much longer. Like as an attacker, what we would then want to try to do is look up like, what valid SQL could we do? What can we try to accomplish? What we do know, the big hint here is from the error, we know that this is a SQLite database. So there's certain queries in SQLite that are very specific to SQLite that can let us enumerate like what other tables might exist. We know that we are talking to the locations table, but we'd like to know maybe there's other tables that exist within this database. So one thing that we could do, and I'm sorry if I'm moving fast here, but we can add in a union select. And the union select is a SQL statement that will make another SQL statement and then combine them together. So if we wanted to, what we could do is do something like union select name from SQLite master. This, I had to look it up, but if you Google it, is a default table in SQLite that lists all the other tables. If we try that, we get an error, but we get a different error. We get selects to the left and right of union do not have the same number of result columns. This is important because one thing that happens when we do select is that the number of columns need to match. One easy way to get around that is to actually select two things. We can actually just select like one common name. And now this database query worked, and we see some weird data here. Instead of hero names and locations, we see one, and then we see a name. And these names are actually the names of the SQL database that exist. So we know that locations exist, but there's another table in this database called identities. And that sounds really sensitive for Justice League if maybe they're keeping track of all the secret identities. So the final, if we add on union select star from identities, we actually are now querying and we get data from a completely different table that we should not have access to. And instead of, it still says hero name and location, but this is not the location. This is actually these heroes' secret identities or their true identities. So we're looking that Adam is Ray Palmer and Batman is Bruce Wayne. Super sensitive information that we shouldn't see, but we were able to see because we were able to break out of a SQL statement and query data from a different table within the same database. I went through that one really fast, but does that make sense? I'd encourage you, this site is not going anywhere. It's gonna be up. So I know we're over time already, but I would encourage, feel free to keep poking around, see if you can recreate these vulnerabilities, try putting in some special characters, try writing some additional SQL, see what we can find when it comes to, the SQL injection or the other vulnerabilities. I'll pause there because I know we're over and people are probably hungry. It's been a long morning. There's more vulnerabilities here. Is it useful for me to keep going? Would you rather poke around a little bit more and maybe a different day, or I can send out slides or answers later and show you the other vulnerabilities, or what are people's thoughts?
Yeah, you can send out the slides afterwards. Then we can have them go through it on their own time if they want to.
Okay. Yeah, perfect. Let's do that. I'm happy to come back to if you want to have like another session later on and just like review some of the more other vulnerabilities that are in here. But keep playing around, keep poking around. I guess I will give you hints. Both of these Oracle search pages are vulnerable to cross-site scripting, so that's what you should be looking in here. Location database is SQL injection. This credits form does not do any sort of CSRF protection, so it'd be interesting to see if you could create a CSRF payload that could steal someone's credits. Batcave we already did. And the secret key, I will just say this fetch key has a really bad CORS policy. So you might want to review the slides and then take a look and burp and play around and see if you can figure out what's wrong with this secret key API. I shared the slides in the Slack channel. Has anyone been able to access them? I just want to make sure that the permissions are good on those.
Yep, I have them open right now.
Okay, perfect. That sounds good. Well, I won't go back into the slides, but I was just going to try to wrap up with just saying thanks for having me. I really hope this was helpful and informative, and at least got the creative attacker juices flowing in your brain, so you can kind of start thinking like this. It really does help as you're designing and building applications to think about, how would I break this, or how could I bypass this? It really kind of can inform the decisions you want to make as a designer or an engineer. Does anyone have any final questions or thoughts on web app security just from that? It's a huge field, so that was just scratching the surface. Probably could have taught a 14-week course just like you all are in, purely on security. But hopefully that was a good overview.
Oh, that was awesome.
Yeah, very interesting stuff. Thanks.
Yeah, thank you all. Thanks again for having me. Nothing is going down. Everything is up. That server is hosting it for free. So that web app is up there. Feel free to keep poking around. Now that you've got Burp and Firefox installed, if you're curious, you can do this on other apps. I want to be clear about that ethical thing I talked about, is make sure you're testing either apps that you have permission for, you're not doing anything malicious, but even just like reading your Gmail emails and while Burp is open and taking a look at everything that Google does. I mean, it's very complicated, but it's cool to see under the hood of everything that's actually happening on a site like Google or Facebook that uses React heavily. And if anyone has any questions or wants to reach out, my emails are flathers@gmail.com or ropnop on Twitter. And if you're also so inclined, the full source code for this Watchtower app is on my GitHub as well, so you could actually take a look at that if you'd like.
Awesome. Thank you, Ronnie. Thank you for spending the morning and part of the afternoon. That was really interesting. That was awesome.
Great.
All right.
Well, thank you all then. I guess I'm probably the only thing between you and lunch, huh?